and then we're going to open exercise underscore SWR folder, and then we got week 3, day 6 file, right? So I think we're going, we will continue using this. Okay, so just double click this and open the open RStudio. Okay, so the first thing we are going to do is we're going to select all, okay, by pressing Control A and run everything. Okay, anyway, so you just want this view box open, you just close it. And then this is day 2, okay, so we are going to add some session. Okay, so right now, what we are going to do is we are going to talk about, and okay, we are going to just review generate and replace function, okay? And replace function. We won't take too much time. Okay, so I think you already noticed, okay? For patients, we can, what we can do is, okay, so we will generate a new variable called average, okay, by, okay, first we need to have an idea of our data set. So we look at the codebook, okay, so we are going to generate average data set based on the average of these two variables, okay. So we're going to generate, okay, since we are using pipe, we don't need to mention the data set, okay. So what we are going to do is we're going to generate a new variable or a new variable called average by taking average of, we can just say mean of test 1 and test 2. Okay, so what we are going to do is we are going to create new variable. Okay, it is a part of data management. So the first method we are going to review, because we already discussed this, is generate. So we will generate. Okay, so you just have to mention the name of the variable you want to generate. Okay, so average, and how do you want to generate it? By taking average. Okay, so we will combine test 1 and test 2, okay, and then we will, okay, test 1 and test 2, and then we will divide by 2, okay. That is very what we want to. So we will add 2 value, okay, from test 1 and test 2 and divide it by 2. Okay, the reason we put parentheses is we want this addition to happen first, okay, so we want this addition first and then multiplication later. Okay, okay, and then what we are going to do is we will just print out a few, print out this average test 1 and test 2, okay, so we will subset our data, okay, so consider this as an exercise, okay, so we only want 3 variables, test 1, test 2, and average, because we want to look at the value, okay, whether they are correct or not. Okay, so this is how you check it. Okay, so apparently we will generate, okay, so average variable, and then we will just print out these 3 variables, okay. And you can also view, put a view like this, but it is not necessary in this case. We just want to check a few variables, okay. So we can do like this. But remember, when you are going to assign this back to the whatever name you want, and you need to remove this one, okay? Because we just want to check our calculations are correct or not, okay? But first, we need to, before we generate this, okay, we need to correct our test one and test two, right? So what we are going to do is we are going to replace, which we already know, okay? So replace if replace this test one with NA, okay? If test one is equal to minus 99, okay? And then the same with test two. Test two equal minus 99, okay? And then we will feed it to the generate function, okay? And let's run it again, okay? Let's run it again. Okay, so we should always, you should always take note that when you make a calculation on one of the missing value, you will always get a missing value, right? Okay, so this is the idea. Okay, so I think you get it, right? You get the idea. So basically, this is how we first write our code and test it. Okay, and after that, you need to assign it back. So you delete this whatever checking, whatever function that you use as a checking mechanism, and then you assign it back to, okay, let's say we'll say this is finder, okay, patient finder, and then we run this. Okay, so you will see we have a patient finder data set with these variable fixed, okay, corrected. Okay, this is how you manage your data. Okay, so first you write a code, and then you check whether your calculation or whatever you have done is correct, and then you put it back to the data set. Okay, you can put it to the original one, or you can put to another one. Okay, another data set. Okay, so I think you already know. I think you can use generate and replace in different scenario. So right now, what we are doing is we are creating new variables. So there is a new function called egen, okay, which is the extended function for generation or generate. Okay, so that's why egen. So where in very often we want to categorize our continuous variables, something like age or BMI. Okay, so we want to convert them into categories. Okay, something like age, different age interval and different BMI interval, like normal, obese, pre-obese, obese, and then something like that. Okay, I think normal, overweight, pre-obese, and obese. Anyway, okay, so these are the example. Okay, so I think we have both variable, age and BMI. Okay, age and BMI. Okay, so anyway, we will continue doing this. Okay, so we will change age into how. Actually, we have to specify how we convert or how we categorize. Okay, let's write this. Categorize age into 10 years interval. Okay, to be easy, 10 years interval. So we will use egen. So we will say patient. We will put the patient data set. And then let's continue using it, egen. Okay, so I think before we use egen, let's take a look what egen is comprised of. Okay, so egen, so you put a question mark and egen and then read the documentation. So we got the egen function. We will use the data set, and then we have to specify our variable. Okay, which variable are we going to categorize? So we want to categorize age. So we will put age here. Okay. So for egen, these two are the essential one. Okay. So you can just specify these two and it will automatically categorize into 10 years and over based on the minimum value. Okay. So let's first look at this one. Okay. So we will just say okay. Uh, because we use the magnet piping function, we do not have to mention the data set. So we just put the variable age. Okay, so we just write egen age. Okay, and see what happens. Okay, and then we will look at the code book. Okay, what happens to the code book? Okay, so let's run this. So you will see there is a 26 variable, which is age dot get. Okay, which is a factor. Okay, so basically what it did is the egen function takes the variable and categorizes into 10 years and over. Okay, 10 years and over, and then it create a new variable with the extension dot category. Okay, whatever whatever continuous variable you are using. Let's try to do that with the BMI. Okay, and then we will put this one piping. So on the fly, we are creating two new variables and categorize them. Okay, with two lines of comments. So you see now we got 27 variables, age.cat and BMI.cat. So each one is a very handy handy function, which you only need to put the continuous variable. Okay, so at least this variable should be a numeric variable in order to work. If it is a character, it doesn't work. Okay. Okay. Anyway, but actually, egen automatically works everything. But we have to think that we have to look at the result, check the data whether it is what we want or not. Okay. So I'm going to delete this. Okay. I just want to demonstrate it. I'm going to delete it, and what we are going to do is we are going to tabulate this age.get, right? So this is the correct one. Okay, so you see the problem with this we have 357 variable, right? So I think we need to change it first. Okay, so this one we will replace age NA if age greater than 100. Okay, like we always write. So we will say replace age with NA. Okay, if NA greater than 100. So this is basically the idea. And then we will run it again. So it should reduce. Okay. So the problem with this is the 10-year interval, the automatic. This is called the automatic labeling. Okay. So you just put one variable and everything is done for you. Okay. But you need to understand that whether this categorization may not be your, what you want. Okay. So actually, this is not what we want. What we want is we want to say, okay, it starts from 34, so we want less than 40 category. Okay, 40 to 39 category, 40 to 50, 49 category, and then 50 to 59 category, and 60 to 60 plus. Okay, we want something like that. We do not want 10-year interval starting from the minimum value. Okay. Okay, so how do we do that? So we have to specify what is called the get argument. Okay, how do we want to get? Okay, so what you need to specify is the initial value. Okay, so you can you can ignore the first label, or okay, so let's try to do that. Okay, so this one is starting from minimum 34, and then we want to go up to 39, right? And imaginally, okay, let's write here, our category should be like this. Should be first, okay, say 34 to, essentially it is less than 39, okay? And then second category should be 40 to 49, okay? And so on, 50 to 59, okay? And so, etc. So I think you got the idea, right? So whatever we mention in the cat should be the first, I mean, should be the lower bound, okay? So we specify here, okay, you can write this 34 or not, it's up to you, okay? So we say 34, and then we say 40, okay? The second category start from 40. The third category start from 50, okay? And then the last category should be 60, okay? So this is how you, I mean, try to categorize your category. So when you specify this lower bound of the label, and when you run it, okay, so everything change. So if you look at the number also change, okay? So less than 40, there are only 4 people aged less than 40, okay? Between 40 and 49, only 42 people, and between 50 and 59, 69 people. Okay, so this is how egen works. It's really easy. Otherwise, you have to use a lot of if-else programming. Okay, so you can just specify this one, and everything is done for you, even the label, right? So this is LBL is called label. So this is automatic labeling. If you don't like it, you can change it. Okay. So how do we change it? By specifying label. Okay. So before we go to label, we can give it a new, I mean, automatically it is age.get. Okay, whatever it is, it takes the original variable name and put the extension .get. Okay, now we don't want that. Okay, what we want is we want to give it, okay, the new name as okay, what do we want to give the new name? age_cat. Okay, so this is a name, so we have to put it in a bracket. Sorry, quotation mark. Okay, so let's run that. Oh, wait a minute. Yeah, so because we changed the variable name, so we have to change the tabulation too. Okay, because the variable change name and name is changed. Okay, so that's why there is an error. Okay, so this is how you tweak this egen function. Okay, let's put the last one. The last one is the label. Okay, LBL. And then you have to be careful that right here we have 4 categories, right? So you have to make sure that whatever label you are putting, you have to specify 4 values. Okay, so usually what we do is for a first category, you can say the lower bound like 34 to 39. So this is specifying the lower bound and upper bound. Okay, which many articles of journal, scientific journal, they also ask you to specify the lower bound. But anyway, the usual way we did is okay, less than 40. It is okay. The first category is less than 40, and then we go on 40 to 49, and then 50 to 59. Okay, and then you don't do greater than or equal 60. Okay, you don't do this. The reason is if you do greater than or 60, these labels are text. Okay, so there is a mechanism for the when you tabulate it, so R automatically arrange this one to be alphabetical order. So whatever you put a symbol in front of the text, then your symbol will be ordered first. So we don't want to collapse. I mean, we don't want to put this category there. Okay. Anyway, I will show you a demonstration. Let's say we were do greater than or equal 60 for the last category, the last label. Okay. And then when you run this, okay, I think it works. Okay. Anyway, I think it works. I think the reason it works is because it is a factor. Okay, but usually it's a good idea to do 60 plus. Okay, the same meaning, but it will be sorted alphabetically. So yeah, I think that you can do both way. Okay, anyway, this is how you do the categorization. Okay, it's really easy. I mean, this is just a few arguments, and then you get all the categorization. Okay, so you can categorize you can categorize into, I mean, multiple categories as much as you want. But always remember that this, when you specify the label get the level or the value in the label should be correspond to the level. Okay, but when it is a missing value, it's okay if you don't specify. Okay. Okay. Anyway, this is how you use egen. Okay. So I think one of the perhaps you can do it yourself. Okay, homework is you categorize BMI based on the BMI classification. Okay, I think you can just Google it for a BMI classification. I think it starts from okay 18.5 and then 24, but I don't remember easily. Okay, so you can do that by yourself. You can try. Okay, so here another thing you should notice, with the generate and replace on this test one task do, we assign it back to patient file. Okay, patient file now. Okay, but here actually, because we are demonstrating, but it is not a good way to manage your data. Okay, because we should be consistent on using the same data set. Okay, so when we are using patient and make changes along the way, and then we should also continue using the change modifying data set. Okay, not take the original data set and modify it again. Okay, so, if you do like this, you will have many different versions or data set. Okay, so one way to do is that you can just remove this. Okay, and you can just put a pipe in here. So basically our code works. Okay, we already checked our codes, and then so everything is correct. Okay, except here it is checked in our data set, check in our variable, so we don't need to assign this to the data set. Okay, so what we want is we want our patient data set. Okay, we take our patient data set, replace test one, replace test two, generate average, and then we replace age, generate this age underscore cat. Okay, and then you run it and put it back to patient final. That's the idea. Okay, so so one of the powerful thing is you see we can leave blank here. Okay, this is just to make, I mean, this is quite easy for us to read the codes, okay, and put the comments. And actually, it is the same flow. Okay, starting from this, the same line of flow. So you can either do this, or if you don't want to do this, you have to take this back here and then start from a patient finder. Okay, or you can use the same flow, or you can use different flow, and then you just join the data set, okay, again and again. So I think, I mean, keeping the same pipeline is important. Okay, so we are going to keep this, and then further, I mean, when we do, when we make further, when we changes, essentially whatever we changes, we will put this back again and again. Okay. Okay, so you can do BMI and then categorize into, okay, name it as BMI underscore get. Okay. Okay. So I did it is how you use egen. So far, we can use generate, egen, and replace. Okay. So the next thing is to recode. Okay, to recode values. I mean, this is the same as replace. But if you consider replace, it works differently, right? So if you think carefully, replace requires a condition, right? Or a replacement. I mean, basically a condition. Conditions or conditions, okay? It's okay. Like, okay, like we did here, okay? So if greater than 100, and then we replace this one, okay? Recode is a little bit different. Recode is, we have values. We want to replace, value, that value, okay? There is no condition, those value. So we have values, and we want to replace that value. Say, let's take a look at our data set again. Okay, we can look at sex, okay? We can look at sex variable. I think based on our experience, sex already have 3 value, right? Like this. Okay, so we can directly recode these into 1 and 2. Okay, 1 if female, 1 if male, and 2 if female. Okay, so you can write replace, but you have to write 3 lines. Okay, replace sex if sex is equal to 12.2, but we will do it only one. Okay, with 1 line. Okay, so what we will do is we will take this one. Okay, we already changed in the patient underscore final, so we will take the data set, and then we give we push it into the pipeline typing, and then we say, okay, recode. Okay, what do we recode? Sex. Okay, first let's take a look at recode. Okay, question mark and then recode. So recode is basically, we mention our data set, and then mention which variable you want to recode, and you mention the old values, okay? And then mention the new value that you want to recode. Okay, so it's quite simple. So you mention the old value, the order doesn't matter here, okay? You can put whatever you want first. But if it is a string, then you have to put it into with quotation, okay? So we want to recode sex variable, okay, with these old, I mean, you do not have to write every value. You just have to recode whatever value you want to recode. Okay, so actually we want to recode everything, so we have to write everything. So female and then male. So these are the old value that we want to recode, and then what is the new value that we want to recode it into? So we'll say Okay, if there is the corresponding new value for 12.2 is there is invalid value, so we will say it is NA. Okay, for female it is 2. Okay, for male it is 1. So you got the idea, right? So what we'll do is we will check it with the tabulation. Okay, we check the result of the sex by tabulation. Okay, so if you use replace, you will have the same result. And you see, if you use replace, then you have to use 3 lines. Okay, so recoding is a very efficient way to just to modifying the value of a variable. Okay, so this is how you recode. I think let's give you another example. Okay, I think why don't we give this example? Okay, smoking ages. Okay, so we say smoking ages and run this. Okay, so wait. So this will give us the smoking ages variable. So actually, you can recode just to replace one value. Okay, so let's imagine for a smoking ages variable, we want to recode -99 into NA. Okay, so we will say that. Okay, why don't we write this? Recode smoking ages -99 into NA. Okay, so recode smoking ages. And then old value is -99 and new value will be NA. Okay, so you don't have to write everything. Okay, you just want to you can just put a few values and it still works. Okay, so you can see that it is now NA. Okay, so this is how you use it. You use the recode functions in R. Okay, so do you get it? Any questions at this point? So if you don't want it, I mean, if you are satisfied with your result, then you just, delete it. Okay, but I think let's make another example with the with a numerical variable. Okay, something like length of stay. Okay, length of stay. So first we will tabulate it. Okay, so you see that there is no, I mean, it's a little bit tricky. Okay, especially when you're using with the this one. Okay, so when we tabulate the length of stay, it starts from 3, 4, 5, 6, 7, 8. So this is length of stay in days. Okay, so imagine if you if it is more than 5 days, we will collapse the this level. Okay, we will collapse the level. So we can do this by using replace. Okay, so we can use replace. If the length of stay greater than 5, then we say it is 5. Okay, so what we want to do is we want to collapse length of stay if, okay, that is great, if greater than 5. Okay, if it is greater than 5, we will say it is 5. So we can do this by replace or recode, the same one. Okay, so we will replace length of stay with 5. Okay, if length of stay greater than 5. Okay, so see what happens. And then when you do this, we will get 3, 4, 5. Okay, and then 5, I mean, the rest will be collapse into 5. So this is especially useful when you have several categories. Okay, so at some point you will see your category will have multiple levels. Okay, something like more than 10, 50. Okay, but in that case you need to collapse these category, otherwise it is not a good idea, okay, to give it out too much level of category. So the focus is you make 3 or 4 3 or 4 relevant levels, keep 3 or 4 relevant levels, and collapse the remain, collapse the rest as the other level. So in that case, this is a really nice this become really nice a handy function. So we can do the same with the recode. Okay, so in recode, so we will recode length of stay, okay, from 6 to 8. Okay, we can specify like that. Okay, from 6 to 8 as 5. Okay, so it gives you the same result. Okay, I think time is almost up. So if the meeting is disconnected, just join it again. So I think next we're going to look at the next. Okay, next. Okay, we finish recode, and next we are going to look at how to rename our variable. Okay, so if you finish recoding, if you finish your data management, then claim this. Okay, the last one is tabulation. Okay, so tabulation always give you the tabulation, not a data set. Okay, so we need to remove the line. Okay, remove this code book, and then we need to join this. Okay, so we just specify this one. Okay, and then remove this one. But remember, if you are joining and given a space here, we make sure that there is no, these piping should be connected. Okay, they should not be disrupted by some other function. Okay, so actually you can just look at it. Okay, in between of these piping, you can just put the comment. Okay, but they has to be valid. Okay, so why don't we do this? So it is the same line of code, and then when you run it again, it will all come together. Okay, so you see whatever we have done, the function from mstep package will generate this kind of notification. Okay, so how many, the first value, okay, test 1 and test 2 replace with any, 7 observation were replaced with any. And then we got average 109 real value generated. Okay, so I think these are very nice notification of what we have done. So far, these are only one flow. Okay, so I think it is very important to make sure that these should not be disrupted. Okay, anyway, let's go to rename variables. Okay, so the function name is rename. So we will give question mark and then rename, and just take a quick look. Okay, so how do we rename old variable and new variable? Okay, so you mention your data set and you mention old variable, and then you mention the name that you want to convert it in. Okay, and you can also give several names. Okay, rename several names simultaneously. Okay, so first let us call our code book. Okay, so which one are we going to replace? Okay, I think we are going to replace family ages and smoking ages. Okay, so we are going to replace, okay, sorry, rename family ages and uh, smoking ages into family his. Okay, it's better to call his than ages, than smoking his. Okay, his means history. This is just to demonstrate you how to use rename. Okay, and then we are going to rename language day also. Okay, so why don't we say language day? Language state is too long. Okay, so we will probably say state uh, duration of stay. Okay, so DAR stay, something like that. Okay. Um, so I think given name, you need to be creative. Okay. I think I'm going to move this here. So we want to rename language state from the ages, have eggs and smoking ages into this one. Okay. So let's start. So we will use patient finder, then give it into the piping. Okay. After we finish, we will join with the codes above. Okay. So right now we will just give it patient finder, and then we give it a piping, and we say, okay, rename. Okay, first let us rename one by one. Okay, and then we will change it. Okay, okay. So what is the old variable name here? This is the language day. Okay, language day, and then we will change into a new name. Okay, but here you do not need to put it the quotation mark. Okay, so just write last day, and then we will look at with code book. Okay, we will look at a code book, and it should be okay. Let's run this. Okay, okay. So our language state here should has changed to the DAS state. Okay, DAS state. So I think it should. I mean, this should illustrate the point. And then, if we are going to name rename multiple variable, okay, and then you need to put them all together. So with the C concatenate function C. Okay, so we will say, okay, length of state is already there, corrected. So we will just say family ages, and then you can do all these all together. Okay, but this is for the sake of demonstration, so I just split it into two. So this is if you want to do it one by one, and it is if you want to do it multiple variable. Okay, so we will say family his, and then smoking his. Okay, and then we will give the piping and see if it is changed or not. Okay, so where is it? Family his. Okay, here family his and smoking his. Okay, so this is how you rename variable. So it's very handy. I mean, very neat function there. So how do we join? You just write the piping, Okay, and then you remove the data set. Okay, because the data set is coming from the the from the piping function, with we just carry all these modifying points. Okay, so this is the modifying data set, and we put it below. Okay, so this is how you continue writing everything, and then you remove the codebook because this is to check our rename. Okay, rename function. Okay, so now you should see the rename function notification from the rename function should be there. Okay, so variable is rename. Okay, so the next point, so we already done pretty much about generating, replacing, renaming, recoding the variable. Okay, so last one, but not least, is to label. Okay, label variables. Okay, and then we will label data set. But first, we will label variable. Okay. So right now, when we want to run a patient data set or even this data set, we do not have labels in several variables. Okay, so these are the missing. And even if it is a little bit, this is a repetition of the variable name. So we will just replace it. Okay? With an easy one, because we're not going to, this is the example, so we are not going to do every 24 and 25 variable or 27 variable. Okay, we just use the common, easy one. So we will say this age is the age of the patient. It's not very informative. Let's say age in years. Okay, and Mary is a marital status. Okay, so we will say, okay, age to age in years. Okay, and then married to marital status. It's always a good idea to write what you want to do. Okay, and then say family his as to family history. And then you can say that, okay, let's say WBC, RBC, or say BMI. Okay, BMI to body mass index. Body mass index, and then how do we measure it? Kilogram per meter square. Okay, so we are going to replace this. Give it the label. So first, as usual, we start with our data set. Okay, and then we use the labelVar function. Okay, so let's take a look at the label. V is capital. Okay, so labelVar. So this is add or replace label. Okay, you can replace label, but you have to specify NA. Okay, so this is a labelVar. Okay, I think you can do you can you can label multiple variable at the same time. Okay, but first let us do one by one. Okay, so label, and then we will label age into. Okay, this one is a label, so we need to put it into quotation. So age in years. Okay, so let's do it one by one first, and then we will look at the label by codebook, by using codebook. Okay, so let's run this. So you will see the label already changed. Okay, this one is age in years, and if you notice, a lot of things has already changed. Okay, so missing value has appeared because we replaced the missing value. Okay, so this is how you use label. And if you want to use, if you want to label a batch of variables, then you can do it too. Okay, with a combine. So you have to concatenate using C function. Okay, and then what do we miss? Married, and family age his, and then BMI. Okay, and then it's a good idea to go to the next line because you see the label are long, so it's a good idea to read. I mean, if this go beyond the right side, then it will disappear. Okay, you won't be able to read it. Okay, first one is Marida status. Okay, this is not exactly Marida status, but let's assume it. And second one is family history. Family history or what? I don't know. Okay, anyway, the third one is body mass index. Okay, but if your labels are too long, if your labels are too long, always a good idea to put this to the next line. Okay, it depends on how you, I mean, what kind of output uh, your computer is making. Okay, so this is kilogram per meter square, right? And always a good idea to check the closing bracket. Okay, I think even so, I mean, this go beyond. Okay, so let me, okay, okay, so always remember to do this and then put a pipe in there. Okay, so that we can check the code book. Okay, and then after that we will remove that line, remove the code book. Okay, so see, we have body mass index already there, and then we got family history, Marida status. So here there is a character limit of how much this can be displayed. Okay, so I put it around 27 character because if the label are too long, this will be disrupted. Okay, that the appearance of this table will be disrupted. So I put a limitation. You can put you can, I mean, you can put it, but it is not a good idea to put a very long label. So if the label is more than 27 characters, then it will be truncated. Okay, I mean, it will be left out. It will not be, there won't be any error, but it will be left out in this case. Okay, so you can try all these variable here. Okay, and put labels on it. And the last thing is we can label our data set. Okay, what kind of data set it is. Okay, so we will use the function called labelData. Okay, labelData. Okay, wait, we have to put question mark and then labelData. Okay, here, so labelData, you put your data set, okay, and then label. So essentially we are using piping, so we do not have to mention the data set, so we can just directly write the label. Okay, so we can say that, okay, this is a patient data set for demonstration. Okay, so this is just the demonstration is some data set. So when you write this, there will be a data set label. Okay, I think this is the complete, complete picture usage of the codebook. So you can get every piece of information for a whole data set. But essentially these are called the metadata. Okay, data about data. So this is called metadata. Okay, so we haven't finished yet because we need to combine this code to the above code. Okay, so we gave it the piping to the above code and remove the data set line. Okay, and then we remove the testing function, the code function. Okay, so now you're going to see that we have rename label and then we label the data set. So when we run it, it will be put into the patient finder. Okay, so after all, when you check this patient finder data set, then you will see every changes, every modification comes together. Okay, so actually it's a good idea to label these two. I mean this one, age category. Okay, so what I will do is I will just put here age underscore cat small. So these labels should correspond each other. Okay. So the order here is the order here matters. So if you change the order, then uh, you will mislabel your variable. Okay. Age category. Okay. Let's run this again, and then run this. Okay, so now we got age category, okay, which is a factor. It doesn't matter, you can always change it back to the um, character version. Okay, anyway, let's do a tabulation, okay, using the patient finder data set and say age, sorry, sex, and then age category. So you see, age category is already there, and we got sex already recoded with 1, 2, and any. Okay, so this is how you manage your data, and everything starting from line number 134 to this here is one flow. Okay, this is uninterrupted data management flow. So you should not put any codebook or any tabulation inside this piping change or comment. Okay, so this is like a change, or this is like a flow. Okay, so it should flow, I mean, nicely. Okay, there are a few I think we still have a few more to learn, but after logistic regression, maybe if we have time, I will talk about these. Okay, how to, I mean, there are a few functions in the front of the book that we can learn. Okay, anyway, do you have any questions up to this point? So these are pretty much, I mean, the most common types of data management that you will see in a medical data set. Okay, I mean, if you have something like the hierarchical structure or time series data, then analysis will be a little bit different. Okay, but still, I mean, there are some functions that you can manage time series data in from using MStack package. Okay. Anyway, we are not talking about data management specifically. So, okay. So no questions, I guess. So we will stop here now. Tomorrow we will talk about logistic regression. Okay, so linear regression and logistic regression, they are the most common types of regression methods used in statistics. Any fields, okay, business. Yeah, yeah. I will share the today's R script. Okay, I think I type a little fast, so yeah, sure. I will share the R script. So actually, this is how the data management script should be, right? So, and when you use the metric R, the piping, it makes, I mean, it makes data management a lot easier and easy to read and easy to understand what is happening. Okay. Perhaps you already you also watch art tutorials. I mean, if you go to YouTube and look at art tutorials, they will have a lot of, I mean, there are tons of basic art tutorials out there. Okay. But essentially, you need to understand how basic art works, like programming, something like subsetting. Okay. It's very rare for these kind of tutorials to provide you easy to understand data management. Like they were trying to teach you like what is a vector, what is the matrix, and it's very essential if you want to learn R, if you want to become an expert in R or something like that. But I don't think that is something a beginner should will catch up at an early stage. So even so, talking about them, confuse everyone. So okay, anyway.